So today we're we'll do this today and tomorrow. Area between curves. We've done area under the curve, right? The middle one. The middle one here, area under F between two bounds. So this is what we've been doing, right? Area under the curve from A to B, okay? Today what we're doing is this, between two curves, okay? So the idea is not that bad. You find area. If you want to find area between, you find the entire area, right? You find the entire area. You subtract the part that you don't want, and you get the area between the curves, right? Not anything you guys haven't done before, but it's just with calculus. But the idea is that find the entire area, find the piece you don't want, subtract that away. That's where the subtraction comes from, okay? And since they have the same bounds, you can put it together as one, okay? As one expression or equation, okay? That's the idea. That's the whole idea today, okay? So again, this is kind of just saying what we're doing today. So in other words, we're taking the top curve and subtracting it from the bottom curve, okay? So whatever the top curve is minus whatever the bottom curve is, wherever the bounds go, we're finding the area there. Some of these questions are calculator, some of them are not calculator. So just depending on what the question is, but all the questions are going to be done the same. All the questions that are like this are going to be done the same, okay? So here we go. Steps to find the area between the curves or between graphs. If not given, draw a picture. Trust me, drawing a picture helps. A lot of these, especially the ones on Delta Math, they're going to give you a picture. But if they don't give you a picture, draw a quick sketch, because sometimes it's hard to see which one's the top curve and which one's the bottom curve unless you actually have a picture in front of you. Okay, so that's very important. Okay, sometimes they won't give you the bounds. You have to find the bounds sometimes. Sometimes they will give you the bounds. It just depends. So if not, you have to find those. Once you do that, you just find area. You plug it in, top curve minus bottom curve, and you do it. Okay. Once you get to this part here, we've done this before. It's just kind of getting to that point. Okay. Okay, so since we've done kind of stuff like this before, I'm just going to kind of jump right in. So let's look at the first example. Okay. So the first example, they'll always give you the equation. They'll always give you the two equations. They'll always give you the top equation and the bottom equation. This one I also gave you a picture. This one's got a picture. Okay. This one has a picture with it too. So we don't have to draw it. Okay. So it says we're finding area, find the area between the two functions from 1 to 2. Okay. So in other words, we're finding this area, right? Okay. So what we're going to do is we're going to find the area of the entire thing underneath x squared plus 1. And then we're going to find the area underneath y equals x, subtract them, we get the green stuff. Okay. But we're going to do that all in one. Okay. So the equation said, so to find area, said take the integral from a to b. Well, they give us the bounds here. Not too bad. They've given us the bounds. So we'll go from 1 to 2. Okay. Now top function. Again, top function is extremely easy because they have a picture in front of you. Okay. So we know what the top function is. We know the top function, the top curve is x squared plus 1. So we're going to say x squared plus 1 minus the bottom. which is x. Dx, because it's with respect to x. Let's see. And then they didn't say we can use our calculator in here. Nowhere on there did they say this is a calculator question, so we got to do by hand. All right. Okay, so before I integrate, I'm going to distribute the negative here. So it's x squared minus x plus 1 dx. Okay. Antiderivative. So when you do antiderivative, you're going to get 1/3 x cubed minus 1/2 x squared plus x from 2 to 1. Okay. Plug in 2, plug in 1, subtract them, we're done. So 1/3 x squared cubed minus 1/2 x squared plus x minus 1/3 x cubed minus 1/2 x squared plus x. Okay, so I'm going to plug in a 2. Going to plug in a 1. See what we get. Let's see, 1/3 minus 1/2 plus 1. Okay, so the 2's cancel out. Over here, 8/3 minus. Then over here, common denominator for the two fractions. Common denominator for the two fractions is going to be 6. So you're going to have 3, 6, and 2. Oh, no, the other way around. 2, 6, and 3, 6. So you're going to get negative 1/6 plus 1, which is 5/6. So you get 8/3 plus 5/6. Common denominator, again, is going to be 6. So you'll have 16 over 6 plus 5 over 6, 21 over 6. Leave it as a fraction. Actually, no, you can reduce that. Let's see, 7/2. Always leave it as a fraction. Did I do something wrong? What did I do wrong? Oh, yeah, I'm supposed to subtract, yeah. I added, there we go. So we're going to get 11/6. So, perfect, thank you. 11/6, leave as a fraction unless they say round, okay? Or if it's a multiple choice question and the answer is a decimal, usually for non-calculator, they're not going to make you divide because they know you can't use a calculator, okay? Not too bad, right? The process isn't that bad because you've done it before. Once we got to here, once we built the equation, you guys have done it before, right? I'm telling you right now, the hardest part, there's going to be 2 hard parts here. One, they don't give you a picture. So you got to determine which one's the top function and which one's the bottom function. Sometimes it's easy, sometimes it's not so easy. Draw a picture. 2, finding the bounds. They won't always give you the bounds. Today, I think most of them will give you the bounds, okay? But finding the bounds might be a little difficult, okay? So let's look at the second one. So the second problem, this is no calculator. They give you a picture, okay? I want you to do this one. Do this one on your own. I'll give you guys 3, 4, 5 minutes, okay? Do this one from beginning to end, and we'll go over it. So for this one, keep working. I have a question. They don't give us the bounds. They don't tell us the bounds in the prompt. Now, from the graph, I can realize that, the bounds of the green are pretty obvious, 0 and 2. But how do you know they're not pulling a fast one on you and that's not 0? That's 0.1. Or that's not 2, that's 1.999. How do you know they're not pulling a fast one on you? Is there a way to check? There is a way using the calculator, but this one's a non-calculator question. So is there a way to check to determine if these bounds are actually 0 and 2? How can I do that without a calculator? What do I do? How do I check the bounds to see if those two red dots are x equals 0 and x equals 2? How do I do that without using, there is a way using the calculator. 100% there is, but this is a non-calculator question. Not allowed to use calculators on this. And I'll show you how to do it using a calculator, but how do we do it without a calculator? How do we know if those bounds are 0 and 2 for the green stuff without a calculator? Yeah, you ready? That's it, yeah. Set f of x and g of x equal to each other. If you set them equal to each other, they both share this dot right here. Oops. They both share this dot here and this dot here, right? The parabola is doing this. The line is doing this. They both share the exact same space here and here. So if they share the same space, they got to be equal. So we would set f of x and g of x equal to each other and solve for x. So it's just a quadratic. Add x to both sides. You get negative x squared plus 2x equals 0. Factor negative 1x. You get x minus 2 equals 0. Set that equal to 0, both of those. Set negative x equal to 0. Set x minus 2 equal to 0. You're going to get x equals 0, and you're going to get x equals 2. That's how you can tell. Okay, that's how you can tell what the bounds are going to be. Now, more than likely, if they give you a picture like this, they are 0 and 2, but just a way to check, just a way to verify that. Okay, and on a test, they might not even give you the picture. First two questions, I gave you the picture. Next one, I'm not going to give you the picture. Okay, so that's important. Without the picture, you wouldn't have known that. If you drew the picture, maybe you can see that, but that's another way of seeing where the bounds are. Okay, so we got 0 to 2. Okay, distribute the negative, that makes a positive, so you're going to have 0 to 2, negative, and then you're going to have plus 2x dx. Okay, when you distribute the negative, and then negative, so it's going to be, oops, let's see, negative 1/3 x cubed plus 2x squared divided by 2 from 2 to 0. So negative 1/3 x cubed plus x squared from 2 to 0. Plug in 2, plug in 0, you're done. So if I plug in 2, let's see what I get. Two, 2, 0, 0. So luckily the zeros, everything's multiplied by 0, so the zeros will cancel out nice. The 2's, you're going to get negative 8/3 plus 4 minus 0. Let's see. 4 is 12 over 3. So that's going to be 4/3, positive 4/3. Okay. All right. Okay, so next one. Here we go. So find the area of the region bounded by the functions f of x equals e to the x, g of x equals x, and the vertical line 0 and x equals 1. Okay. Now they don't give you a picture. Unless you know your functions, and even if you do know your functions, it's kind of hard to picture in your head without seeing a picture, which one's the top function, which one's the bottom function. E to the x is exponential. X is just a line with a straight line with a slope of 1. And then it says the vertical lines x equals 0 and x equals 1. Those might be the bounds. I'm not sure. So the first thing I always do for these problems is draw a picture. Draw a picture and see what's going on. Take the first couple minutes, draw a picture, and see what's going on. Multiple choice questions, they will never give you a picture. Never, ever, ever for this. Free response, they will always give you a picture. So it just depends on where you see these. These are the questions you're going to see in both. You're going to see in FRQs and in multiple choice. Okay? So that's why I'm giving you both. Okay, so e to the x. E to the x is a exponential. How do exponential graphs look? There you go. Yep, do that. Do that again like that, right? They start out slow, and then they pick up very, very fast. They're exponentials. They grow the fastest out of all functions. Boom. All right, that's how they look. E to the x looks something like that. Okay? This guy here is also increasing, but it's just a straight line. Increasing, but not as fast. Vertical lines, 0, x equals 0, and x equals 1. Vertical lines. Those are vertical lines. Okay? So we're going to draw all of that together. So I'm going to start with the vertical lines, because those look like they might be the bounds. So there's x equals 0. X equals 1. There's another vertical. Okay. I'm going to draw the line next because that's the easiest one to draw. So g of x. So when I plug in 0 here, it's just x. So whatever x is, y is going to be. So when at 0, x is going to be 0. Let me use a different color. And then at positive 1, x is going to be positive 1. I'm not concerned what happens after because it looks like those are the bounds because it has to be within 0 and 1, those two vertical lines. Okay, that's g of x. F of x. F of x. What's the value at 0? What's the value for e to the x at 0? Positive 1, yeah. E to the 0 is 1. Okay, so I'm going to have a dot here. Let me change colors again. Good. So this one's going to start there. And then at 1, where is it going to be? At 1, where is this guy going to be here? When x is 1, where is the graph going to be? E, right? At E. It's going to be E to the first, which is around 2.7, 2.8, around there, right? All right, so let's go. So I need to extend my graph a little bit up. Okay, so it's going to be 2. I'm going to draw my red line a little bit up. Okay. So, oops, I got to draw it up a little bit. Got to draw it up a little higher. That's 3. E is going to be approximately like right here. Oops, I didn't use green, I used blue. It's going like that. Okay. And then the green's going like that. Okay. So it looks like the area in between is going to be right here. That looks like that's where the area in between is. So I don't need anything below because something happens below. Okay. So it looks like our bounds are 0 to 1. E to the x is the top function minus x dx. Okay. Didn't say anything about using a calculator. Nothing about using a calculator, so non-calculator. So we're going to have to antiderivative. So luckily, the antiderivative of e to the x is just e to the x. Minus 1/2 x squared from 1 to 0. Okay. Okay, so e to the x minus 1/2 x squared. And then do that again, but for 0. Okay, so I'm going to plug in 1, plug in 0. So I get e minus 1/2. And then over here, I get 1 minus 0. Okay. So e minus 1/2 minus 1, which is the same as e minus 3 over 2. Okay. Sometimes they'll want you to combine those. Sometimes if it's multiple choice, they'll want you to combine them to say common denominators. So they'll say 2e minus 3 over 2. That might be an answer too. I don't know. Just depends on what the multiple choice. Either one of them is okay for free response, but if it's a multiple choice question, which this one most likely is because they didn't give you the graph, you're going to have to match. So either one. Okay? Either one. All right. Okay, so now let's look at the next one. Okay, so now we're going to introduce calculator problems now. These are calculator problems. The last couple years, one of the calculator problems has been one of these types of questions. Okay, they'll ask you to do area between the curves, and then they'll ask you something about volume. We haven't done volume yet. We'll get to that next week. But for area, they'll always give you a picture on FRQs if it's a calculator question. Okay. So they gave us a picture. We're going to find the area of R. R is the area. Okay. We have it there. Okay. So We know which one's the top one. The top one's the curve, the parabola. That's f of x. G of x is the straight line, x plus 2. So I should use r instead of a. So we're going to say top, negative 4x squared, plus minus the bottom, okay, dx. It's a calculator question, which is nice because we can just plug all that into the calculator. But we're missing the bounds. So the bounds of the green stuff are right there and right here. I can do it by hand and figure them out by setting them equal to each other, setting f of x and g of x equal to each other, but I can already see what the answer is going to be. It's going to be like 0.4, 0.3 something, and then 1.4, 1.45, something like that. It's going to be an ugly decimal. Okay, so I can already see that. That's why these are calculator questions. They give you the calculator for one reason, and it is if they don't have the bounds. There's no bounds. Okay, so we're going to use the calculator for the bounds. Okay, so I'm going to show you how to do that. And then since it's a calculator question, we can also use the calculator to solve it too. They didn't say what we could and couldn't use for the calculator for. If they say we can use a calculator on this question, we can use it on every part of this question. Oops. Okay. Okay, so we need to see where they cross. They cross twice, right? We know that from the notes, they cross twice. Once around x equals 0.3, 0.4, once around x equals 1.3, 1.4. Okay, so we're going to need to use a calculator. There's no other way to do this unless you have a calculator. Okay, so let's graph them first. First thing we're going to do is graph them because we can't do an integral unless we have bounds. Okay, so we're going to graph them first. Y equals. So we're going to put f of x first. So negative 4x squared plus 8x. That's the first one. The second one is x plus 2. Okay. Zoom decimal. Oops. Got to see that. If that happens sometimes, that's a box plot from stats class because someone else used the calculator. So you got to turn off the first plot off. If it's your calculator, that won't happen. But if it's one of our calculators, we use them for stats as well. Zoom decimal. Okay. It's the picture we have, right? That's exactly the picture we have. Well, if you go to calculate, the button right above trace, here. If you go to calc, it gives you some options. Anytime you want to calculate anything from a graph, that's where you're going to go, calc. We use that function when we want to calculate something from the graph. Okay? Do we want to calculate a y value? Do we want to calculate a 0? Do we want to calculate a maximum, minimum, intersect, derivative, or area under the curve? Well, we're looking for intersect. We want to know where f of x and g of x cross. So that's the one we want, number 5. Okay? So it'll ask you, where's the second curve? Doesn't matter which one's first and which one's second. Well, that's one of them. Wait, what the heck happened? Let me try this again. First curve, there we go. First curve is the blue. Second curve is the red. It doesn't matter order. Order doesn't matter. Okay. And then it says guess. Where do you think it could cross? So we're going to put the cursor over where the closest we can come to. Hit enter. And then it's going to give us the bounds. We're going to go 3 decimals in. 3, always go to the thousandths. So 0.360. 0.360. That's going to be our lower bound. That's going to be our lower bound. Okay. 0.360. Make sure, because it'll mark you wrong. It won't give you points for the calculations if the bounds are off. So I've had people round 0.3, 0.4. That's not good enough. You got to go 3 spaces, 3 decimals for that guy. Okay. We only want the X because that's the bounds. We're going to do that again, except we're going to do it for the other intersection. Okay, there's the first curve, there's the second curve. Best guess is right about there. The second intersection happens at 1.390. We're going to stop right there, 1.390. 1.390, that's the next. Okay. Once you have the bounds, plug the rest into the calculator. Once you plug the rest into the calculator, you'll get the actual area. We don't have to do antiderivative because it's a calculator question. Math, integral. If you ever get a calculator that doesn't have this when you're trying to find an integral, it has something else, let me know. Don't put it back in there because it needs to be updated. I thought I updated all of them, but there's a few, I guess, that weren't updated. So if it ever gives you something like that, let me know so I can update it, because it's easy to update. I just need to know if it needs to update it. Okay. So our lower bound was 0.360. Our upper bound was 1.390. Okay. Our top curve was negative instead of minus. You always want to use negatives if you want negatives, minus if you want minus. X squared plus 8x. Parentheses, minus, and then x plus 2. Make sure all parentheses are closed. Enter. There's our area. 0.730. The problem said round to the nearest thousandth. It said round to the nearest thousandth. So 7.30. Okay. Right. Okay. Okay, so let's see here. No, I don't want to do that one. Let's do this one. We'll do this one last. This is the last one we're going to do. Okay. Last one we'll do, and then we'll leave the rest. We'll leave this stuff till for tomorrow in terms of why. Okay. Okay, so here we go. This is a calculator question, so we can use calculators. They give us a picture. They give us f of x. They give us g of x. What are the bounds going to be? Which one's top function? Which one's bottom function? What are the bounds going to be? They change, right? So first thing you do is when you look at this, you're like, oh, the bounds are from 0 to like 2.5, 2.5. Top function is this guy here. Bottom function is the line. It changes, right? It changes right here, right? Top function and bottom function switch, which is about 1.6, right? So we can't use just one. We can't use one equation. We can't use one of these guys here. We can't use one of these guys because they switch. Top curve isn't top curve anymore. Bottom curve isn't bottom curve anymore. Top curve is only the top curve from a specific point, right? So top curve, let me go back to the question. So this guy here is the top curve to that point. From 0, it looks like 0 to that point there. So that's the first thing we got to do. It's two problems. These are two problems into one. Two problems into one. So we have to do two separate problems, and then we're going to add the areas together. Okay? All right. So I'm going to call this one R1, and I'll call this one region 2. Region 1, region 2. Okay? Okay, so for region 1, it looks like it starts at 0. It looks like it starts at 0 and it goes to about 1.6. Top function is the parabola. Okay, so negative x squared minus 1.5x plus 10 minus the bottom, which is the linear. Okay, dx. How do I find the top bound? Or the bottom bound? Actually, it does say, what does it say? Oh, it says 2.5, right? It does say 2.5. It does say the dotted line is at 2.5. So I don't need to find the bound, because it says this line right here is at 2.5, and the line x equals 2.5. Okay, so I don't need that. Good. Okay. So what do you get? Oops, this guy needs an x. So crunch that. What do you guys get? What's R1? Yeah. Hmm? Oh, sorry. Yeah, you're right. The bound would be 2.5. Yeah. So we still have to find the bound. Yeah. That's the outs. That's R2. We're not at R2. So how do I find the bound? Still go back to the same question. Hmm? Good. Do it. Try it. Yeah. If you need a calculator, if the tub of calculators is open, that means we're going to use them. Okay. That's what they're there for. So if you need a calculator, grab one. Grab one, because you're going to need to practice. So I want you to find the bounds. Okay. I want you to find the bounds, and I want you to find the area, the overall area. Okay, I'll fix it. Thanks. All right, I'll give you 4 or 5 minutes. Okay, calculator. So when I graphed it, it was off the graph. So I got to change the zoom or just change the center. So anytime you want to change the graph center or the zoom or anything, just you can change the window, or I just say zoom in, and then I tell it where I want to zoom in. That didn't work. Maybe zoom out instead. There we go. Enough you can see enough where you can see where it crosses, right? So we got to see where we know it's going to be the left side's going to be 0. We know the left side here, the left edge is going to be 0. We're just trying to find this guy right there. Okay. So second, calc, intersect, first curve, there it is. Second curve, there it is. Best estimate, there we go. And that's what we're looking for. Go 3 spaces past 1.6598, so 1.660. That's the bound we want, 1.660. Okay, that's the top bound, 1.660. Okay. Then you go back, put in your equation, and you're done. Okay, so let's see here. That'll be R1. So then we got to go calculate R2. I don't think we're gonna have time to calculate R2 today, but at least we'll have R1. So math, integral 0, 1.660. Start over. And then parentheses, negative x squared minus 1.5x plus 10 minus negative 0.75 x plus 6. Now this will happen to me. Sometimes I'll get a syntax error. Sometimes I'll hit enter and I'll get an error, syntax error or something like that. That means, most likely that means something related to the parentheses or the negatives. Like yesterday I did this and I got an error because one of my negatives, I wrote a minus. Calculator doesn't like that. Okay. So R1 is 4.082. 082. That's R1. That's the region 1. Okay. So tomorrow, first thing we're going to do is we're going to go and calculate region 2. First thing I'm going to do is I'm going to have you guys do it on your own. Okay. Using the calculator, I'm going to have you guys come up with region 2. We're going to add them together, and that's going to be the region there. Okay. All right.